Hi, welcome. Let me introduce myself first. I am Prem Shankar, BTech student of NIT Patna, and I am recording this video just for the demo purpose. So, in this video, I am going to teach you the basic concept of the light. So, let me write the first topic name. So, it is already written, the light. So, tell me, what's the first vision, what's the first concept that comes in your mind when you first listen the term light? So let me define the light for you. What is light? According to me, or according to the definition of the physics, light is the form of energy which gives you a sensation of vision, a sight. Suppose, let's take an example. Whatever we are visualizing around us, that is due to the light. Suppose you are watching a vehicle, and what's the concept, what's the core concept behind that visualization? So the core concept is that when the light falls on the vehicles and the reflected ray comes to our eye and forms a real image, or you can say vertical image, whatever it may be might possible, on the back side of our eye, that is called retina, or we call retina is also called as a screen, and image is found here. So this is due to the reflection property of light, image is formed and we are visualizing the things around us. So this is all about the light. So when we are talking about the light, we have to also talk about some basic properties of the light. So I am going to give some basic properties of the light. So the first property is that light travels in a vacuum medium or every medium, but in vacuum speed of the light is 3 into 10 to the power 3 into 10 to the power 8 meter per second. This is the speed of the light in vacuum. When medium changes, a speed of the light changes. A speed of the light gives the measure of the medium's bearer or rancer. If the speed of the light decreases from 3 into 10 to the power 8 meter per second by a huge a significant margin, then the medium is denser. And if speed of the light changes a little bit from the 3 into 10 to the power 8 meter per second, then it suggests that medium is rarer. So the second properties of light is that light always tends to travel in a straight line. In technical term, this is also known as the rectilinear propagation of light. So this is the two basic properties of the light. Now let me discuss about what is reflection, what is incidence. So let me erase first. So let's see what is incidence. Incidence is defined as the light ray falling on the surface, or you can say object. This is defined as the incidence. The second one is reflection. Reflection is defined as the property of a light which tends to bounce back after striking a reflecting surface. Okay, so when it comes to reflection, then there is a two law which is known as the law of reflection. According to the law of reflection, first law is that angle of incidence, which is denoted by angle I, is equals to angle of reflection, it is denoted by angle R. The second one is the incident ray, the reflected ray, and the normal ray all lie in the same plane. So let's understand it from the diagram of the law of the reflection. Suppose this is the reflecting surface, this is the reflecting surface. Let's first draw this is the normal, this is the incident ray, which is denoted by I. Now after reflection, this is the reflected ray, which is denoted by R. So this is the angle, this angle. The angle between the incidence ray and the normal, it is known as angle I, or you can say the incidence angle. The angle between the normal and the reflected ray, it is known as reflected angle, angle of refraction. And according to the law of reflection, according to the first law of reflection, you can say that angle of incidence is equals to angle of reflection. And what second law of reflection says, that the incident ray, this is the incident ray, the normal ray and the reflected ray all lie in the same plane. This is the plane, all lie in the same plane. So this is all about the laws of reflection. Now let's move to the learn about some basic concept of image. So what do you understand by image? According to me, the image which is formed by two types, or you can say by two ways. If the light rays, you can say if the reflected rays, two reflected rays intersect at point, at that point an image is formed. And that image, in this case, when the two reflected rays appears, when two reflected rays appears to meet at a point, or not actually meet in real, then that type of image is formed. Is virtual image. And the image which is formed by the actual meeting of two or more reflected rays, that is termed as the real image. So the virtual image and this is the real image. Now take a look at what is real image and what is virtual image. The basic characteristic of the real image, or you can say see the difference between the real image and the virtual image. The first basic difference of the real image and vertical image is that real image is always formed on the screen. In our case, in our eye, this screen is retina. The virtual image is always formed behind the screen. Remember, this is not formed on the screen, this is always formed on the behind the screen, or you can say behind the mirror, deep inside the mirror. The second one is real image is always inverted. Okay? Whereas virtual image is erected. Okay? Real image is always inverted. What is mean by inverted? It means inverted means, suppose this is the object than the image formed which is at of this type. Inverted means in Hindi you can say inverted means just opposite. This is the object, this is the opposite of the object, and this is the image form. This is known as inverted. And what is erected in case of the virtual? Just say this is the object, and this is the, suppose we take a plane mirror. Plane mirror also form the virtual image, and this is the image formed behind the mirror. Okay, so this is the in object, this is the image formed, and this is erect image. Okay, so this is the our concept of real image and virtual image. Now let's move to the type of the mirror. How many types of mirror do we have actually? So if we talk in the large sense, we have generally two types of mirror. We have two types of mirror. First one is plane mirror, and second one is spherical mirror. Spherical mirror. So let's talk about the plane mirror first. This is M, this is N, this is the, and this part is the shiny part, or you can say the reflected part. Okay, when you put an object here in place of the plane mirror, it will go to the mirror and it will reflect from here following the law of reflection, and we extend this reflected by here. Suppose we take this and form a images here. So the basic characteristic of plane mirror is that image. The basic characteristic of the plane mirror is that image which is formed by the plane mirror is always behind the screen, or you can say deep inside in the mirror or inside the mirror. This is the first basic concept of the image formed by the virtual mirror. The second is the image formed by the plane mirror is always virtual, or you can, as I have said earlier, that when image is formed behind the screen, it is automatically a virtual image. So I have just said that image is in case of plane mirror, image is formed behind the screen. So by using this concept, you can also suggest or say that image is virtual. But the best part of the plane mirror is that the image is formed is of the same size as that of object. So in other terms, we can understand this concept from magnification. Magnification is what? Magnification is defined as the ratio of height of image formed upon height of object. So in case of the plane mirror, magnification is 1. And the image is formed by plane mirror is virtual and erect in form. Or you can say one more concept is that plane mirror gives us the lateral inversion. What is mean by lateral inversion? Suppose we write A, B, C, D, E, F. This is the written on somewhat. When mirror is placed before this, what we see in the mirror? We will not see this in the mirror A, B, C, D in this form. We will see the mirror, but in its inverted form, like A, B, C, D, E, and F. This is a, you must have noticed in the ambulance. There is written at the side of the A, M, B, U, L, A, and C ambulance. When you see from your car mirror, it is seen as the opposite. Yeah, you can say lateral inverted. This is all about the mirror formed, image formed by the plane mirror. Now let's talk about the other part of the second part of the mirror, that is a spherical mirror. A spherical mirror. A spherical mirror, basically there are two types of the spherical mirror. First type is concave mirror, and the second part is convex mirror. Right? So this is the concave mirror. This is the colored part, and this is the colored part. So this is the concave mirror. This is the reflecting surface of a concave mirror, or you can say the surface faces towards the center of the sphere is known as the reflecting surface in case of the concave mirror, and in case of the convex mirror, the bulking part is the reflecting surface in case of the concave mirror. Suppose this is the reflecting surface. In case of the concave mirror, this is the reflecting surface. Let's talk about the type or characteristic of the image which is formed by the concave mirror and the convex mirror. So the image formed by the concave mirror is, at most cases except one case, image is real, inverted. There can be of different magnification. In case of the convex mirror, in most of the cases, image is diminished. And the image is formed by the convex mirror is virtual and erect in every cases, but in most of the cases, image is of diminished. You can say magnification is less than 1 in most of the cases in convex mirror, and magnification can be 1, less than 1, and greater than 1 in case of concave mirror. So let's see some basic predefined rules for forming the ray image. Before studying or before moving to the topic that how ray image is formed, so from the name here itself suggests that ray image. What we can conclude from ray, that when two rays, suppose this is the concave mirror and two ray, this one is the one ray and second ray, this is the second ray. So this is the first ray, this is going parallel to the principal axis, and after striking the mirror, it comes after passing the focus. And other ray, which is also going parallel to the principal axis, and after striking, and both there meet, they form the image. This is the concept of the rayoptics. So there is 3 or 4 rules predefined for forming the ray optics. The first rule is that when incident ray is parallel to principal axis of mirror, after reflecting, it passes through the focus of the mirror. Focus of mirror. So let us understand by the figure. So this is a convex mirror, Mn. Let us draw. This is the pole. This is the focus. This is the center of curvature. This whole constitutes the radius of curvature. So what the first rule suggests here, and you can say this is the principal axis. So first, what is the focus? Focus is the distance, or prime focus. Focus is the distance between the focal length. Focal length is the distance between the pole and the primary focus of the mirror. This is the this is the pole, and the distance between this is known as the focal length. What is the object distance, which is denoted by u? The object distance is the distance between the object placed at the pole of the mirror is known as the object distance. And what is the image distance, which is denoted by v? The image distance is the distance between the pole and the location of the image formed is known as the image distance. So we are talking about the rules of the ray image. So first rule says when an incidence ray is parallel to the principal axis of a mirror. So this is the incident ray which is going parallel to the principal axis of the mirror. And what does it? After reflection, it goes from passing through the focus. So this is the parallel incidence ray parallel to the principal axis, and after reflection, it will pass through the focus. So this is the first rule says. Come to the second rule. The second rule says that when incident ray falls on the mirror, at focus, after reflecting from mirror, reflected ray will pass through the reflected ray will go parallel to the principal axis. So this is the concave mirror, this is the pole, this is the principal axis, this is the focus, this is the center of curvature. So what's it? When incident ray falls at focus, this is the incident ray, this is falling at focus. According to the law, when incident rays fall at the focus after reflection from here, it will become parallel to the principal axis. So this goes like this, parallel to the principal axis, and this is the second law. Rule. Not law. The third rule says that when light ray falls on the center of curvature of the mirror, it retraces its path after reflection. So this is the concave mirror, this is the principal axis, this is the pole, this is the focus, and this is the center of curvature. According to the third law, rules, when light falls on the center of curvature, so this is the center of curvature. When light falls on the center of curvature after reflection, it bounces back or retraces its path, or you can say it goes back to the same path from the center of curvature after reflection. This is the third law. Fourth law says that when an incident ray fall at the focus of the mirror, fall at the pole of the mirror, it will follow the law of reflection, and the angle of incidence will be equals to angle of reflection in this case. So let's see here, this is the concave mirror, this is the principal axis, this is the focus, the center of curvature, and this is the pole. So what is the fourth law? When incident ray falls at the focus, pole of the mirror, it will go like this after reflection by following the angle of law of reflection, which is angle I is equals to angle R. So this is all about the fourth law, by using which we form the ray image in the ray optics. So I'm not going in deep about how to make the ray image. I'm going to define the mirror formula by using which we can solve the numerical. So the mirror formula is 1 by u plus 1 by v is equals to 1 by f. So you must be worrying about what is u, what is v, what is f. So u, what is u? U is the distance, object distance. What is object distance? Object distance is the distance between the location of the object and pole of the mirror. This is known as the object distance. What is v? V denotes the image distance, and the image distance is defined as the distance between the pole of the mirror and the location of the image where image is formed. What is the focal length? F is focal length. Focal length is the distance between the primary focus and pole of the mirror. This is known as the focal length. So stand from it. For example, this is pole, this is focal, this is center of curvature. So what is u? Suppose we placed a object here. So the distance between this from here to here, this is u. When image is placed here, suppose object is placed here, image formed here. So the distance between this and this is v, and the distance between the prime focus and pole, this is known as the focal length of the mirror. So from this, by using this concept, we can define the magnification. First of all, what is magnification? Magnification is the index which gives the core concept about what is the image formed, is how many times or how larger or how diminished from the height of the object. So magnification is defined as the ratio of height of image formed upon height of image or height of object. So magnification is written as h dash over h, where h dash represents the height of image and h represents the height of object. Or by solving this one mirror formula, 1 by u plus 1 by mirror, magnification is also written as minus v by u, means the distance of the image formed by distance of the object, and it is also equals to the height of image h1 or height of the object h2. Now it talks about the what this magnification says. When magnification is positive, it means image is virtual, and if image is virtual, it's automatic that it will be erect. And when magnification is negative, it suggests that image is real, and when it is real, then what it so that's all.